Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you. Welcome back team and let's continue our discussion. We are discussing about the Jenkins CI and CD pipeline, which is the continuous integration and the continuous deployment pipeline, which will take care of building and deploying your application automatically start from the Bitbucket repository to your Kubernetes pod, right? We'll see how the CI and the CD pipeline works and how to implement the pipeline in the environment, right? So I think we have spent some time in understanding how the Jenkins pipeline architecture works in terms of how the Jenkins will do the build and the deployment by integrating all the different tools that we have. And we have theoretically went through the functional architecture, how the Jenkins will take care of the build and the deployment process. So today, let's get started in doing the execution a step-by-step process. So it will be a little tricky and definitely we may feel that why should we be struggling too much in setting up the Jenkins, rather it's very easy to go and do a manual. But the effort that we are putting in here to prepare a Jenkins CI and the CD pipeline is not just a one-time task, right? Once you set it up, right, the forever it is going to do the job for you, in the sense it will take care of doing the automated builds each time when the developer is pushing the code. That way I don't need a DevOps engineer to be available to do the build process every time when there is a code change. That is the significant advantage that we are getting in here, right, preparing a Jenkins pipeline. As I said, the Jenkins is the automation tool, right? So whichever the task that you may feel that repetitive, manually executed, right? Those things will be given to the Jenkins and the Jenkins will be executing them on behalf of you. Is mean that the Jenkins is not just for the Java build and deployment. Jenkins is not just for taking the source code and building it and deploying it. Jenkins is the automation tool which will be executing the task on behalf of you. It could be any task that you like to. Getting me? Right? Any task that you hand over to the Jenkins, which will it will just go and execute it whenever you are expecting it to be done, right? That's how it works. So based on the different use cases, the Jenkins may use for different purposes too, but primarily it is using for the pipelines, the CI/CD pipelines, because CI/CD is the mostly repetitive task that I'm expecting to be done, right? Because every time the code changes, it has to be done. So this is the small summary that I wanted to reiterate from the yesterday's session. Are we good with this, guys? Now, I spent a lot of discussion in making you guys are understanding this whole architecture. When it comes to the implementation, the proper planning would be needed, right? So here I can probably let me open the different folder. So what I'm doing is I have prepared a plan how we can go with this implementation process, because there are multiple steps that are involved here in order to set up the Jenkins from very scratch. So first let me go through this plan, then I will start implementing them one by one. Look like I have total 8 steps that are there here and that I wanted to implement one by one today. Out of these 8 steps, if I go from top, help me guys in the chart window. My primary focus is first I need to have the Jenkins master application is up and running, correct? So I need a Jenkins master running in my Kubernetes cluster, which will be taking care of the whole CI/CD process. As we know, the Jenkins master is actually creating and executing the actual steps that needs to be on the slave. So I need to create a Jenkins slave. In the sense, I need to prepare the Jenkins master. I need to prepare the way how the Jenkins slave will be created. Then when I say a Jenkins master, right, I'm expecting the Jenkins master to be running as a pod in the Kubernetes cluster, right? If it is running as a pod in the Kubernetes cluster, definitely you need to create an image, correct? There should be a image, right? There should be a image that will be for running the Jenkins application. And we know that the Jenkins should be attached with the service account so that the Jenkins will be gaining the permission to connect to the API server in order to create the slave pods automatically when there is a need of running the specific job related tasks. And to deploy the image that I have created for the Jenkins master, I need to have the manifest files, and eventually maybe you can create a Helm charts as well as optional. Right now, either you use the Helm chart or the manifest file to do the deployment of the Jenkins master in the Kubernetes cluster. Are we good with the first step? The Jenkins master has to create the Jenkins slave pod automatically. If the Jenkins master has to create a Jenkins slave automatically, it must know which image that it has to use to create a slave, right? So you need to create one more image. That image is being used by the Jenkins master in order to create a agent. Agent or slave, both are same terminology. So create one more Docker image for a slave, and you inform to Jenkins master that, hey master, use so and so image in order to create a slave pod. Then whenever it has to do the build or the deployment or any specific steps that needs to be executed, right, it will use this slave image and create a slave pod, right, or the slave Jenkins pod, and the tasks will be get executed on that particular one. So far so good. Now, so once you have the images are ready, I have one image for Jenkins master, I have one image for my Jenkins slave. Then you start deploying this Jenkins master into the Kubernetes cluster, right? So now the Jenkins will be up and running. Once the Jenkins application running, then we need to inform or configure the Jenkins how it has to perform the total CI/CD process. Where I'm expecting the Jenkins is doing the whole CI/CD process in terms of cloning the Bitbucket repository, then doing the Maven build, then doing the Sonar integration, then pushing the Maven artifact to the JFrog, then doing the Docker build, then pushing the Docker images to the registries, then creating the Helm charts and pushing to the JFrog artifactory, right? This is the whole different stages that are involved, the pretty much minimal mandatory stages that are involved in terms of the build process or the CI process, right? In order to do all of these stages automatically, right, the very first thing is the Jenkins would need the credentials that it has to use when it is integrating with the multiple tools. Always think like this. If you need to do all these different stages manually, let's say if I ask you, please clone the source code from the Bitbucket repository, you would need a Bitbucket credentials, correct? If I ask you, right? Push the Docker image to the Docker registries. You would need the registry credentials. If the Maven has to push the artifact to the JFrog, it would need the JFrog credentials, correct? The Sonar as well. So if you are doing all these stages manually, then definitely you will be supplying the credentials as and when needed. But when you are expecting the Jenkins to do these steps automatically, definitely the Jenkins has to supply the credentials automatically. Think of like the Jenkins is just a human replacement. Whatever you are doing manually, the Jenkins will do on behalf of you, no difference. If then you need to, right, keep updating the Jenkins. Hey Jenkins, you please use these credentials. I meant to say you need to inform to Jenkins software that you please use this so and so Bitbucket credentials, use so and so no the registry credentials, use these JFrog credentials, and use the service account if you wanted to connect it to the API server to do a slave pod creation. You just need to inform all these credentials to the Jenkins. How we are informing or how we are saving these credentials in the Jenkins, we'll see in an implementation. I'm just trying to look at the different resources that would be needed to set up my Jenkins pipeline. This is just a planning. When the Jenkins is integrating with the multiple tools, just to call out one more time, I'm expecting my Jenkins to work with Bitbucket, Maven, Sonar, JFrog, Docker, Helm, Kubernetes, correct? How would Jenkins know that it has to integrate or how it has to integrate with all of these tools, correct? In the sense, the Jenkins must aware of how it has to work with the Bitbucket. It should aware of how to work with the Sonar. It should aware of how to work with the JFrog or the Kubernetes, correct? Think of like a human, right? As I said, if I ask you, hey, please go and work with the Kubernetes and do the deployment, you must be knowing, right, how to connect it to the Kubernetes, how to run the commands, and how to do the integration, correct? Same way, the Jenkins must be aware of how to integrate with all of the different tools that it is using in this whole build process or the deployment process. By default, when you install the Jenkins software, the Jenkins will not come up with any of these integrations. In the sense, by default, the Jenkins will never be aware of any of these tools. It doesn't know how to work with any of these tools. Just a plain software that you get it. Whichever the tool that you are expecting to be integrated with the Jenkins, that tool specific plugin has to be installed on the Jenkins. Plugin is just a top-up software or the additional software that we are installing on the Jenkins so that the Jenkins will make use of this plugin software to understand and then to do the integration to that specific tool. In my case, in my project, I may be using Jenkins to integrate with the Maven, Sonar, JFrog, Kubernetes. Maybe in a different projects, the Jenkins might be using for a different tool sets, correct? It may be using for Gradle, maybe Nexus Artifactory, maybe different other tools as well possible. So whichever the tool that you are expecting to be integrated with the Jenkins, you try to install the specific plugin. That plugin will give some add-on functionalities, add-on benefits, or add-on features to the Jenkins. Then the Jenkins will know how to work with that particular tool set. So at a high level, if I look at the different plugins that I would be needed, I would say that Git is one of the plugin that needs to be installed on the Jenkins. The Git plugin will give will add a feature to integrate with the source code management systems like Bitbucket. Maven plugin will help the Jenkins to integrate with the Maven tools. Docker pipeline plugin will help to work with the Docker in terms of creating the images and pushing the images to the registries. Kubernetes plugin will help the Jenkins to understand how it can connect with the API servers in order to create a dynamic agent slave pods in the at the time of it is running the build or the deployment steps. When I'm expecting the Jenkins is running some specific list of commands that have been specified as part of the build and the deployment process. Let's say if you ask the Jenkins that, hey Jenkins, can you please go and run the git clone command and you clone the source code to the local. To run the git clone command, the git software has to be installed, correct? So what are all different packages that must be needed to be installed in order to run the specific set of commands? I would say the git package has to be installed, the Java package has to be installed, Maven package has to be installed, the node has to be installed if you are expecting the React.js builds, Docker to be installed, then only the Docker build and the Docker push commands can be get executed. kubectl must be there if it has to run the commands to connect with the API server for some related things, and Helm must be installed in order to do the Helm packaging. Helm push artifactory plugin must be installed in order to push the Helm charts it into the JFrog. Are we good with this? The list of packages that would be needed on the build server, correct? No, all these are the packages must be there on the build server where I'm trying to run my build related commands. For now, I'm just focusing on right. For now, I'm focusing on how I can do the build process. Help me guys, as I see in the chart window. Do we need to worry about the Tomcat, especially when I'm trying to do the build process? Not really, right? The Tomcat is something will be there at the deployment side. When my application is running, then I would need a Tomcat in order to start the application on port number 8080 somewhere, right? So while you are building the source code, I don't need to worry about the Tomcat. So I'm not worrying about installing the Tomcat as well for now. Now tell me guys, all these different packages must be there in where? All these packages must be there in the Jenkins master. All these packages must be installed in the Jenkins master. No, right? All these packages must be there in the slave Jenkins where exactly my steps are being getting executed. So you prepare a slave image. In the slave image, you need to ensure that all these packages are installed and you keep that image in the Docker Hub registry, which I'm calling it as a builder image. Right? So in general, can I use this statement at this time, guys? The Jenkins master, the Jenkins master, of course, it's difficult to visualize the things because we did not see the Jenkins at all so far, but that is still be fine. The Jenkins software, if it has to create a slave Jenkins to do the build process, and I'm saying that the image that it is using to create a slave pod, the image is carrying all the required packages to be available to execute the commands. If that is the case, if I ask my Jenkins that, hey Jenkins, can you please take the Python code and do the build and deployment? If I ask my Jenkins, hey, can you take the Java code and do the build and deployment? I may ask, can you take the React code and do the build and deployment? I may ask, can you take the .NET code and do the build and deployment? What does it mean, guys? The Jenkins is now capable to do the build and the deployment of different programming languages. Each programming language may have a different build tools, different set of commands, correct? And eventually it may need a different set of packages to be installed, correct? If it is a Java code, probably I need to have the JDK and the Maven as mandate. If it is React application code, probably I don't need a Maven, I don't need a JDK, probably I need a node software, correct? So in general, it's not a best practice to keep all these different packages it into a single builder image like JDK, Maven, Node, maybe .NET related build dependencies, Python related build dependencies, right? It's not a good idea to keep everything it into a single builder image and creating a single slave, right, to do any type of the builds, which which is unnecessary. You are adding up multiple dependencies, packages, right, multiple capabilities it into one single image, and the image size will go bigger and bigger. Getting me? Let's say when my Jenkins is creating the slave to execute the React builds, what is the point of me keeping the Maven and the JDK related packages also in the same machine, correct? In the slave, I don't need them, right? Literally, which is unnecessary, causing more delay in terms of pulling the images and loading the image, running the container, which I don't need because the image size is more because I'm keeping many things into a single image. In the sense, when you are creating the image that the Jenkins master can use in order to create a slave pod, I can create multiple images. You see here the Node agent image, Python agent image, Java agent image. You can do like that. You create a separate Docker file for Node agent image and you build it and you create a one image. You prepare another Docker file and you build it and you prepare another image for Python agent, and you prepare another Docker file, you know create an image, and that is for the Java agent. The Java agent image will carry all the packages that are needed just for the Java related builds. Node agent image will have the packages that are needed only for the React application or Angular related application builds. That way, when the Jenkins is building the source, if it is a Java source, it will just use the Java agent image and create a slave pod, and it will just perform the Java related builds. If the source is Node, it will use the Node agent image and then it will create a slave pod and it will just execute the Node related commands. Will that be sounds good, guys? How I can tell to Jenkins which image that it has to use to create a agent pod to do the build? We'll see it in the configuration in a while. But I'm just giving more information so that we'll understand this in a better fashion. So then once you get a code from the developer, right, it's your responsibility to add the required Docker files in the Bitbucket. This Docker file is for your application deployment. Then you keep the Helm charts there, right? Then you keep the Jenkins file there. In the Jenkins file, you put all of the different builder related commands, right? Then you keep the build pod template. In that, you need to tell exactly. You see this in the build pod template, which I'm keeping in the Jenkins file. I'm going to inform that, hey, which builder image that you need to use to create a slave and to run the commands. This is the trigger. In this build pod template, if I say you take the node agent image, it will take that image and create a slave and run the commands. If I tell you take the Python agent image, it take that and do the process. That's how you are actually telling to Jenkins master which image that it has to use to create a agent that is going into the Jenkins file under the pod template configuration. The deployment side, you have a different Bitbucket repository. You maintain the different branches. Each branch is like an environment. You maintain the environment specific values files and the pipeline configuration, and that will be taken care of. So when it comes to the action, the Jenkins will take that specific builder image and create a slave, and on that slave the steps will be get executed, and finally that will be taking care of deploying it into your target Kubernetes. So all these are the resources that I'm calling out just for planning the things what and all needed or what and all that I need to give to my Jenkins to take care of the whole automation. The same thing I just have prepared in the sequential fashion here. To deploy the Jenkins master, I need to have the image, I need to have the service account, and I need to have the manifest. To deploy the slave, I need to have the image. Then you deploy the Jenkins master using the manifest files that you created before. Then in order to set up the Jenkins, right, we need to install all these plugins. Then you set up the Bitbucket credential, Sonar credential, JFrog credential, Docker. Then you tell to Jenkins which and all tools that it has to work with and how to use those tools. I mean to say, you need to tell to Jenkins, right? Hey Jenkins, this is the Sonar Cube URL. This is the JFrog URL, correct? If you are doing manually, right? You will just directly go to the JFrog account, you log in manually and you try to do the stuff. If the Jenkins is doing automatically, the Jenkins must aware of what is the URL that it has to use for connecting to the JFrog, correct? You need to supply all the information. That is what is it mean by setting up the tools. Then prepare the Docker file for application container image, prepare the Helm charts, then create your CI pipeline and put all of your steps. Then create a CD pipeline, put all of your deployment steps. That's a high level sequential steps that we need to follow. Can we start with the step number 1 now? Well, so let me start with the step number 1, and before that I can show you that I have the Kubernetes cluster running. Let me see, AWS EKS update hyphen kubeconfig name ed hyphen EKS hyphen 0 region US East 1. Well, so kubectl get nodes. Well, I have the Kubernetes cluster ready. kubectl get pods. This is the brand new Kubernetes cluster. I don't have any pods that are running in the default namespace. Even I can show you that hyphen hyphen all hyphen namespaces. This command to give you the pods that are running in all the namespaces. You can see some of the default pods that are running in the kube hyphen system. I don't have any other customized pods in my cluster. I just wanted to show you that this is a brand new Kubernetes cluster. I don't have anything running at this time. Are we good with this? Now let me start with the step number 1, which is preparing the image and the required manifest files to deploy the Jenkins master in my Kubernetes cluster, right? So of course we can't create a manifest files from scratch line by line, right? We already familiar how to create a manifest files. So let me grab the manifest files that are there with me in my repository and I'll start making use of them. I will share this repository with you guys later. Okay. So for now, let me go to Jenkins master pod. And these are the different manifest files that I have, guys. Let me start doing that. Well, the first thing is I need to have the image to run the Jenkins, right? We can use the Jenkins image that you get it from the Docker Hub registry. If you search in the Docker Hub registry, you can see the Jenkins image here, Jenkins, and you can choose which version of the Jenkins that you wanted to use from the tag section here. The latest will always bring you the latest version of Jenkins, and you can choose whichever the version that you wanted to, as usual, right? So I'm using the Jenkins image that I get it from the Docker Hub registry directly. So I'm using, I'm just deploying this each into my Kubernetes to run as a Jenkins master, right? So that means, so I need not to create an image here because I'm grabbing the image from my Docker Hub registry, correct? Can I mark this step as done? Good. So that means I'm not writing the Docker file and doing all of this because the image is already there in the Docker Hub registry. It's recommended to use the same image that you get it from Docker Hub registry. So just use the image as it is. Now the next thing is you need to create a service account which will be giving the permissions to the Jenkins, right? Let me create a service account for that. Maybe I'm just using the manifest files one by one. Of course, I can do the clone as well, but that's fine. So this is for Jenkins master. So this is for service account. Let me go through this one more time. So the API version is V1. The kind is service account. That means I'm creating a service account. The service account name is Jenkins-admin. Of course, you can give whatever the name that you want to. And the namespace, in which namespace that you wanted to deploy the service account. And here I'm deploying my service account it into the default namespace, but you can choose any namespace that you would like to. In general, tell me guys, the Jenkins has to be deployed it into which namespace? Let's say my application runs in dev, QA, perf, and then the production namespaces is right. So your Jenkins server or the Jenkins software should be run in which namespace? The Jenkins is the one single software take care of doing the build and the deployment it into all the environment, right? The Jenkins is not specific to dev, not specific to prod, not specific to QA, right? The Jenkins is a single Jenkins take care of all the deployments across the cluster. So the Jenkins need not to be in a dev or a QA or the production. It can be in a separate namespace. It can be a default, or you create a namespace called Jenkins and you put the Jenkins software in that Jenkins namespace just to make it separated, right? But here I'm just using the default namespace, that is fine. So since my Jenkins is running in the default namespace, I'm creating my service account also in the default namespace only. That's my plan. Now, coming to the role perspective, since I have already spent some time in the Kubernetes RBAC concept, how the service account concept works theoretically. So I'm just directly going into the manifest file explanation here, right? Maybe a question for you at this time. The Jenkins software I'm planning to run in the default namespace, fine. But I'm expecting the Jenkins to do the deployments it into dev, QA, perf, and the production, correct? That means my Jenkins should have an access to all other namespaces, correct? Then only it can do the deployment it into whichever the namespace that you want it to, correct? If the Jenkins would need the access to the other namespaces too, right? Then you would need to create a cluster wide role. The kind is cluster role. That means the role that I'm creating will give the access to the cluster level. That means it will give the access to all the namespaces, no restriction. Obviously, right? That is what I needed as well, because the Jenkins should have a permission to do the operations on across the cluster, not a specific to the environment or to the namespace. So I'm creating a cluster role here. So when you are creating the cluster role, you need to tell what is the level of a permission should be granted to this role. So you need to have some rules defined here. In the rules you see here, right? Basically there are three different terms: API groups, resources, and verbs. And just look at the resources first. I wanted to give the access to the pods. Pod is the Kubernetes resource, right? For the Kubernetes pod resource, I wanted to give the create pod access, delete pod access, get pod access, list pod, patching the pod configuration, right? Update and the watch. Pretty much these are the list of different actions that can be done on a specific resource. And I'm just mentioning that what and all different actions can be granted for this specific pods. That's how the syntax works. The API group can be empty. That means it can be any API group. So API group in the sense, right? This one, right? In general, for any Kubernetes resource kind that you are deploying, there is a specific API group, correct? Let's say if you are trying to deploy the pod, the API group will be v1. If the kind is deployment, API version will be app/v1, correct? So based on the kind, the API version will be keep changing. That's a constant. You get that from the documentation, right? That is something that I'm mentioning here. Hey, I wanted to give the permission to the pods kind, and this is the API version. If you make it empty, it works for any. If you are very specific, let's say you need to specify v1 here, then I'm precisely telling that the resource should be a pod, the specific API version will be v1, and I'm giving the access to create and delete and all. That's how you are precisely giving the permission to what resources, what API version, all these things. But in general, right, the API version can be empty as well. So that just work for any API version. It can be v1 or app/v1, whatever it is, right? Now, and you see here pods/exec. This resource type will give the access in order to execute a shell it inside a pod. The Jenkins should have an permission to shell into a pod to run the commands inside the pod. Right? That is the permission that I'm giving. Pods/log in the sense I'm giving the access to the Jenkins to look for the logs of a pod. Here you can see that I'm giving the permission to the Jenkins to access the deployments and the replica sets as well. I'm giving the permission to my Jenkins right on the ingress rules, right? So on, so on. So this is how we need to configure the different permissions that you wanted to give here. Out of these, right, I'm skipping few things like a secrets. We'll touch base this permission bit later, right? So in general, this is how we need to tell to which Kubernetes resource and what kind of the permission that you wanted to grant. Like that, you start filling up your set of rules here, and the Jenkins will get these permissions when it is trying to access the Kubernetes API server. So that's how you create a cluster role. Once the role is created, as of now the service account is created, role is created, then you need to do the role binding. So the kind is a cluster role binding, right? And here you need to tell that the Jenkins is the cluster role, Jenkins-admin is the service account, correct? If you go back here, my service account name is Jenkins-admin. My role name is Jenkins, right? I'm telling that Jenkins is the role name, Jenkins-admin is the service account. These two get mapped. That's what I'm doing here. Role binding in the sense I'm telling that which service account should use which cluster role. That's it. Then this service account now onwards will make use of these all permissions because I made the binding process here. Good. Now let me start creating a service account. kubectl apply -f Jenkins, sorry, sa.yaml file. kubectl get the service account. Now we can see that the Jenkins-admin service account is created. This service account is binded to the cluster role that I defined. The cluster role has all the different permissions that I wanted to give. I'm looking into the chart window where the IAM concept coming into the picture here. I'm not dealing with IAM anymore. Anything that I'm talking about here is within the Kubernetes only. It's not AWS concept. I'm talking about the Kubernetes, correct? So in my planning, the service account is created. This service account is just granting the permission to access your API server to access your Kubernetes resources. Very specific to the Kubernetes concept, nothing related to AWS here. Now let me create a manifest file to start doing the like in order to prepare the deployment configuration to deploy my Jenkins. Help me guys in the chart window. Usually what and all files that would be needed to do a deployment it into Kubernetes cluster? You need a deployment manifest file, right? So let me create a deployment. So this is the deployment manifest file to deploy my Jenkins application, right? And at high level, the replica count is 1, definitely. And I'm just using the labels here. At high level, if you see here, this is the place, the line number 19. This is where I'm telling that which service account that this deployment should use to gain the permissions to access the API server. The service account is already created. That service account name I'm mentioning in my deployment file, so that whichever the pod that gets deployed, that pod will use this service account to access the permissions. That's how the pod now will have the access to your API server. And as a pod, the Jenkins application that is running in this pod, right, that will use the service account to access the API server and get all of these permissions. So here you can see that which Jenkins image that it has to use. I'm mentioning that you right pull the image from the Docker Hub registry, and this is the image, and this is the tag, right? And this image will be used to deploy the Jenkins as a master in the Kubernetes cluster. The Jenkins application is listening on two port numbers. One is the 8080 port number. The another one is called as a 50,000 port number. The 80 port number is called as a HTTP port. This port is using in order to access the Jenkins from your browser. The Jenkins will give you a graphical user interface in order to access the Jenkins application to prepare your or to monitor your pipelines. But when you go back to this architecture, right, the Jenkins master and the Jenkins slave, these two to be communicated, correct? When the slave pod is created, the slave pod should be connecting to the master, because the master is actually instructing to the slave what needs to be done, correct? The slave is connecting to the master on JNLP port number, which is 50,000 by default. Looks good. Right? So the any application that is running in the pod will be listening on the specific port number, right? So the Jenkins will listen on two port numbers. 8080 is the port number that you will be using as a administrator to access the Jenkins on the browser to monitor the Jenkins or to configure the Jenkins from the administrator perspective. 50,000 port is being used by the slave if the slave has to connect with the master to do some transactions. That's how it has two port numbers, right? It has to listen on. And going back, right, when I say service account, the service account is mapped to the role. The role terminology that I'm using here is the Kubernetes role, not a IAM role. If you go back to the Kubernetes RBAC concept, I have used the terminology called role, right? This is the Kubernetes role, which is granting the permission to the API server, not a IAM role here. I'm not talking about the AWS concept anymore here. If I come back to this slide again, right, you see the Jenkins master right? The Jenkins master is creating the slave pods. How would it create a slave pods? The Jenkins master should connect to the API server in order to create a slave pods, right? For that, the Jenkins master would need a access to the API server, and hence I need a service account. The service account should be attached to the Jenkins pod, and then the application that is running in the pod will be using this service account to connect it to the API server and do the administrative activities as needed. Good. So I think this is some recommended syntax from this particular image. So I just have used the image security context as it is. Okay. If you look into the Jenkins image documentation, the image documentation will tell you that, hey, please use this config in your deployment file to make it running, and you can use the same. If you go in deeper and deeper to look at what it is all about the Jenkins software. The Jenkins service should be running as which username and which group. That's the syntax meaning, but just make it default. Now let me go ahead and deploy the Jenkins. kubectl apply -f deploy. So I'm deploying it into the default namespace at this time. kubectl get pods. My Jenkins is now deployed with a replica count 1, and the current status is container creation. Let me wait for some time. Now my Jenkins is running as expected. Good. Now let me go back to my planning. The service account is done and I have the manifest ready, right? And of course, I don't need to use the Helm chart at this time, because if I create a Helm chart, pretty much we can't learn much, right? Helm chart is the package of multiple manifest file. If I just directly take the Helm chart and run Helm install command, it takes care of creating all the resources at once, right? So I'm not happy to go with the Helm chart preparation or kind of deployment now. We already know how to prepare a Helm chart if you know the manifest file, right? Just matter of packaging all the manifest files it into a single Helm chart format. That's it. So I'm not doing the Helm chart method at this time. I wanted to deploy the manifest file one by one so that we will know exactly how we are creating the different resources. Good. So with that, I can see this is done, right? The deploy Jenkins master pod, this is also done. Master is deployed. Maybe manifest files, not yet. The master is deployed. The next thing is, once the master is deployed and it is running as a pod, how would I access this application, correct? How to access the application, guys? Create a service, right? It's not about exec. Exec is just for troubleshooting by logging into the pod shell, correct? So in order to access the application, I need to deploy the service. Now you create a service manifest file. What kind of the service that I need to create? You see the kind is service, and of course you need to maintain the same label, the label that you have used in the deployment file. If you go to the deployment, right, which labels that you use in the template section in the deployment, same labels should be used in your service manifest file as well. And the type is a cluster IP, right? Definitely it is a cluster IP, right? And even if you wanted to access this application outside of the Kubernetes, still you can have the cluster IP, and the access will be happen through the ingress, correct? Now if you see the ports here, one port is for accessing the application using HTTP protocol. One port is for a JNLP, which is being used by your slave pods. So we need to mention the both ports information here. So this is the cluster IP service. Let me go ahead and deploy this. kubectl apply -f service.aml file. Done. Now, once the service is deployed, how I'm going to access this application from outside? Because if it is within the Kubernetes, the cluster IP service works, but I wanted to access the Jenkins from outside of the Kubernetes from the public internet space. How do I do that? I need to deploy the ingress controller, right? Let me see how I can deploy the ingress controller. I just wanted to pull my ingress controller manifest file. We did everything already, guys. Okay. In a Kubernetes, I talked about all of these already. I'm just putting together everything in one single session again. No, not new things. Maybe I'll say simply controller.ml file, right? So this is the ingress controller manifest file, and we know how the manifest file works. Simply let me go ahead and deploy the controller manifest files. Done. Let me clear the screen. What is the next step, guys? So then you need to define the ingress rules, correct? When you deploy the controller, that just create the AWS load balancer, but you need to define how the routing has to be done. Probably if I go to the AWS and look for the load balancer here, you see that the load balancer is actually getting ready. Right now we need to deploy the resource. How exactly the routing will happen? Maybe I'll say ingress.ml file. The kind is ingress, and I wanted to access my Jenkins as jenkins.etshopper.com. This is the URL that I wanted to use in my browser. Any request that is coming from jenkins.etshopper.com, right, should be pointing to the Jenkins cluster IP service on port number 8080, and it has to use the ingress class as nginx, which was already deployed. Looks good. Now I'm not doing here www dot. Why? This is not an end user application, right? The Jenkins is just for the administrator purpose, not for the customer's purpose, right? So I'll say jenkins.etshopper.com. kubectl apply -f, I would say ingress.ml file. kubectl get the ingress. Now I can see there is a load balancer ID here, which is mapping to this URL. All what I need to do is I'll go back to the route 53 and add the record in the route 53 hosted zone, right, pointing to that particular load balancer. Create a record. Jenkins.edshopper.com should have the CNAME record pointing to this load balancer endpoint. Done. Now, if I go to the browser and run http://jenkins.edshopper.com, sometimes the DNS may take some time to propagate the changes. I just have added. So now you should be able to access your Jenkins application on this browser to do your Jenkins related configuration, all the stuff. Good. The very first time when you access the Jenkins, you see that the Jenkins is already locked and you need to unlock the Jenkins. This is a very standard first screen that you get it. Even in the real time, you'll get the same screen. This is the very first time when you are spinning up the Jenkins. It is also telling that the administrator password that would be needed to unlock the Jenkins software is available in this specific location. How do I get this password now? Any clue? You need to shell into the pod, right? So this is the location where the password is saved in the Jenkins server, wherever it is running. My Jenkins is running in the pod. So you need to shell into the pod by doing a kubectl exec, right? Then you cat this file, then you should be getting your password, right? That's how it is. Probably I will use K9s. Did I cover K9s, guys? I hope so, yes. Okay, interesting. Okay, so it's very difficult for me to run the kubectl commands every time, right? Of course, now my requirement is I need to run kubectl exec -n on the default namespace as an interactive mode. Then this is my Jenkins pod, correct? Which I wanted to execute, right? And I need to open the bash shell. Then once you go inside the pod, you need to look into this file to get the password. That's a process. Anyway, my kubectl exec will not run because I'm in the Windows machine. This command will not work on my Windows machine. Okay. Either you run this command on the Linux client where you can get the shell. You're already familiar about that process. But anyway, I'm here. I wanted to show you one other beautiful tool for you guys. K9s is the tool, right, which is the substitution for the kubectl. No other difference. Whatever you can do with the kubectl, all these things can be done through a K9s, right? So you can just go to the K9s website and just download the K9s software and start using this. But I'll show you here how the K9s software will be useful. Once you download the K9s software, you just execute the K9s, hit enter. Right, just run K9s, hit enter once you download the software. The advantage with the K9s, right, you will be getting this type of the terminal UI, so that you don't need to worry about running the kubectl commands every time. Let's say now I wanted to know the number of namespaces that I have. Colon ns. You see all the namespaces. Let's say I wanted to see all the pods in my Kubernetes cluster. Colon pods. You see all the pods that are currently running in the default namespace. Let's say here you can see the here you can see the pod, the Jenkins pod. Let's say I wanted to execute a shell into the pod. You see some helper as well in the above, right? D for describe, E for edit, D for delete, S for shell, something like this. If you wanted to describe the pod, just type D, you will get the describe, which is equivalent to your kubectl describe command, right? But you don't need to run the kubectl commands each and every time. This is like very simplest process to get the same output. Escape to come back to the previous. If you wanted to get the shell of this Jenkins pod, just type yes. You see, I got into the shell, right? Now let's say I wanted to look at the file called var lib. What is that, guys? Right? So it is var Jenkins home secrets initial password. This is the location, right? So let me try to, yeah. So this is your password. Let me copy this. Hope you are getting me, right? That is the K9s advantage, so that you don't need to remember all the kubectl commands every time. It's very simple to work with. Now let me come back to the screen. Let me give this password. Click on continue. Good. So the second screen that you see here, right, customizing the Jenkins. As I said, by default, the Jenkins will not come up with any of the integration tools. All what you need to do is install the plugins. The plugin is the top-up additional software that you are adding in the Jenkins based on which tools that you are expecting the Jenkins to be integrated. Here, if you choose select plugins to install, then you need to choose the plugins one by one. If you choose install plugins suggested, then certain default common plugins that must be needed for any project will be installed automatically for you. For example, Git plugin. The Git plugin will be useful to integrate with the Bitbucket repositories or any other code repositories. Do you think is that the optional plugin? Not really, right? Any project that you take on, irrespective of it is a Python or React or Java or any other, right? The base minimum, it need a Git plugin because it has to connect with the code repositories to pull the code, correct? Like that, certain default plugins which are mandatory will be installed for you automatically if you go with the install suggested plugins. It's definitely needed, right? Rather you choosing those base minimum plugins manually, it's better to go with install suggested plugins. Click on that. So the Jenkins automatically installed certain plugins for you. And here you can see the list. It is installing the Git plugin for you, right? It is installing a pipeline plugin, SSS plugin, some email plugin in order to send the emails, right? And we can see few other. If you don't find the plugin that you are looking for based on your project, you can install it later as well. The plugins are installed. Now it is asking you that, hey, can you create your Jenkins user? By default, the Jenkins will have the username called admin. and the password is what I got it from this shell. But you can create your additional usernames as well by creating the user in this form. Either you can create a Jenkins user now, or you skip it and can create a user later as well. For now, let me skip. And this is my username, sorry, URL, save and finish, and start using Jenkins. Here we go. This is the Jenkins UI, guys. This Jenkins is currently running as a pod in the Kubernetes cluster. I'm accessing this Jenkins through the ingress, and I just have logged into this with the default plugins. Are we good with this? Most of the concepts are repeating, right? I talked about a lot of concepts in the Kubernetes before, but today I'm just putting together in a proper sequential fashion or in a proper process oriented, nothing much difference. Currently, I logged into the Jenkins using the username called admin. If you see here, the username is admin. That's a default username. I logged in, and I'll get the complete access on my Jenkins. Do you think you log in as an admin in the real time? Not really, right? No one will give you the complete access on any tool. Based on your job role, whatever the permissions would be needed for you, right? You will be getting the same level of permissions. You will get your own username as well. So in general, if you go to manage Jenkins here, the manage Jenkins is the place where you configure your Jenkins how you are looking for. There should be a place where you can create a Jenkins users as well. I'll go to the Jenkins user here, and I can start creating the user. Let's say I have 5 DevOps engineers in my team who wanted to access my Jenkins to do some job role, right? I can start creating the users for everyone. Now, the PR user will be using the PR credentials to logging into the Jenkins to do his job responsibilities. And I can set up some permissions policies. That's a different thing. So I'm just doing or configuring my Jenkins now, correct? Setting up the Jenkins. Now the question for you. This Jenkins software is currently running from the pod, right? This is my Jenkins pod, correct? This is the pod where my Jenkins is running currently. What will happen if my Jenkins pod gets deleted? Here I am manually deleting, but assume like the Jenkins pod got terminated for any unexpected reasons, right? Your Jenkins pod is deleted for any unexpected reasons. What will be the impact, guys? You see that the Jenkins pod is created again. You see the A is 6 seconds. Why? You said a replica count is 1. It has to maintain at least 1 replica, and it is creating the Jenkins pod automatically for you. So good. But the problem is, of course, you don't need to do anything, any other changes in the ingress or in the service as well, because your new pod is coming up with the same label, right? Then the ingress service will work as it is for the new pod. But the problem is, if I come back and try to access my Jenkins, you see, again I back to the same screen, the first screen. Why? The settings that I have done on my Jenkins, all those settings are gone. Why? Whatever the settings that I have, or whatever the configuration that I have done on my Jenkins some time back, those configurations were saved in the pod. When the pod is deleted, the configuration data is deleted. It is now treating it as like a new fresh Jenkins. The previous data is gone. That means, can I say that at least now the the application that is running in this pod is dependent with the data, right? Any application that is having the dependency with the data, that application we will call it as a stateful application. Sometimes the application, like sometimes the pod gets deleted, one more new pod will be get created, but we don't see any data loss, correct? Sometimes I think in the previous lectures we have seen that behavior, that is just having the application, it just serves some web pages for you, it doesn't keep any data. So if your application is depending on the data, then that is a stateful application. If the application is not depending on the data, that is just running some code base, then that is a stateless application. If this is a stateless application, then you don't need to worry much, right? If the pod gets deleted, you'll get a new pod. You don't need to worry. But if it is a stateful application which is storing some data in it, and if the pod gets deleted, you have a data loss that has to be treated differently. So far, I'm not bringing the slave pod concept here. So right, I'm still trying to figure out how to make my master pod up and running, or my master Jenkins is up and running in an effective way. Remember the Docker concept now. In the Docker, I was explaining about mounting the volumes. I need to implement the same concept here as well in order to store the data outside of the pod, not in the pod itself. How to achieve that now? So whenever you are deploying an application in the Kubernetes cluster to run as a pod, and definitely the application will be accessible using the service account as I said, and the pod may go down and may create it again, and you are seeing the data loss, right? To avoid that, you you take the external volume, in our case EBS volume at your AWS side, right? You take the EBS volume from the AWS and you attach and mount that EBS volume inside your pod. That way, whatever the data that gets created in the pod, the data will be get saved it into the external volume, not in the pod specific storage space. So that later tomorrow, if your pod gets terminated, right? If your pod gets terminated, when the new pod is coming up, the new pod will be mounting the same EBS volume and it can see the same data. That's the whole idea here. Are we good with this? When I'm using AWS Cloud in order to manage my infrastructure, I may be using the AWS EBS volume as an external storage concept, but based on the cloud that you are using, there will be a suitable options to store the data outside of the pod. That's how you need to treat stateful and the stateless applications. Now, how to create a volume, EBS volume, and how to attach this volume to the pod so that it can store the data there. But so far, tell me guys, where exactly the data is being stored? Sometime back also, I did something right. Maybe I'll try to unlock it again. This is my password, right? So you see, here also I'm doing some customization, right? Where exactly it is storing this customization data so far? Some storage space which is a temporary. So when the pods gets deleted, it ensures that the space that is allotted for the pod will also be get deleted automatically. That's a default behavior. That you can avoid it by using the external volume and you mount it in the pod level. So far so good. If you shell into the application pod, right? If you shell into the application pod, if you do df-h, right? You see some folder structure like this, which is all a temporary, guys. Inside the pod, whatever the file systems that you see, everything is temporary. When the pod gets deleted, all the data, whatever is there, the storage space that is allocated, everything will be get deleted. That I wanted to avoid. Good. Now, /var/ Jenkins underscore home is the default home directory where the Jenkins is going to store the Jenkins related data and the configuration. Like whatever the plugins that you install, whatever the users that you create, correct? All that data will come into this particular location, guys. Here you can see plugins folder will have all the plugins that you have installed. Users folder will have all the users that you created. Like that, any configuration, any settings that you do on the Jenkins will be get saved in this particular folder only. So this is the folder that is important for me to safeguard or persist my data. Good with this? That means my requirement is any data that is getting added into the folder, into this folder, that data I want it to be on my AWS EBS volume. Can I use the statement like this? /var/Jenkins underscore home is the directory to be get mounted on AWS EBS volume. Now you need to go back to the Linux file system concept to understand this. When you mount the var Jenkins underscore home directory it into the EBS volume, then any data that comes to this directory will go to EBS volume, and EBS volume is outside of the pod level. And if the pod gets deleted, your data is safe because it is storing in the EBS volume that will be get attached, mounted to the new pod automatically. How do I know that where Jenkins home is the home directory where my data is coming in? That you get it from the documentation. You got the image from the Docker Hub, right? So if you go to the Docker Hub Jenkins image, the Jenkins image documentation will talk about all these things. Right? So if you go to the documentation, it will tell about the details where exactly the data will store, what is the home directory, all the details. Accordingly, you need to understand which folder that you need to use. You see here somewhere where Jenkins home, something like that. Anyway, now let's see how to do this mounting at least for today. Kubernetes has a concept of PV and PVC. PV is the persistent volume, PVC is the persistent volume climb. We'll see what's the difference between these two. Now, you guys should understand the reason why I given you some 4 days of time for you to prepare the Kubernetes, right? Because you should be capable enough to recollect a lot of concepts to understand the concept that I'm covering today. Now, well, so my Jenkins to be get mounted on the external EBS volume, right? For that, the step number 1 is you need to create a persistent volume, PV. The persistent volume is mean that, or the persistent volume is the Kubernetes resource which is storing the configuration of the volumes, how it has to be get created. Like, yeah, you see here, like the persistent volume will have the details about what type of the storage that you wanted to, where the storage has to be created, how the storage has to be created. That kind of the storage class information will be added as a persistent volume, guys. And if you look at here, right, the persistent volume will be having the details like the volumes should be get created on the AWS cloud, volumes to be created of type GB2, volumes to be right created in the dev namespace, something like this. So this kind of the storage class related information will be kept into the PV. Then on this PV, you need to start creating the PVC, which is the persistent volume climb. Persistent volume climb is actual volume, the actual EBS volume that you wanted to. When you are creating the persistent volume climb, you need to tell that, hey, I need this persistent volume climb on the so and so specific PV. Then that persistent volume climb, which is your EBS volume, will be created based on the properties of the PV. That PVC you need to mount it on your Jenkins pod. So step number 1, you need to create a PV. Step number 2, you need to create a PVC. Step number 3, you inform to Jenkins pod that, hey, you please use this volume and do the mounting on the so and so, directory. Those are the 3 steps that we need to follow here. Now, if I ask you one more time, what is the difference between PV and the PVC? PV will be holding of the storage class information. What kind of the storage that it has to use? Is it AWS storage? Is it Azure? Is it Google Cloud or something else? That information will be kept into the PV level. PVC will take the or will use the PV information. Accordingly, the volume will be created on the specific storage and that volume will be make it available for you. Let me create it simply for now to understand it more. What is the first step, guys? Creating the PV. So here you can see the manifest file which says that the kind is storage class, If you see here, what is that I'm telling? I'm simply telling that the volumes, the storage should be get created on AWS. The storage should be of type GP2 volumes. The volume to be on US East 1 year zone. I'm just telling this information in the PV, no other information. The actual volume will be created on the PVC, not on a PV. PV just a general information, right? What kind of the storage it is, from which cloud the storage should come in, right? What kind of the volume, which zone you are expecting to be created. All this extra, the general, storage related information is kept into the PV level. No other reason. If you go to the PVC manifest file, in the PVC manifest file, you see, hey, I need a 10 GB volume. The 10 GB volume, I wanted it to be created by using so storage class name. What is this storage class name? The storage class name is the one which I created some time back, right? When I was creating the PV. This is my PV manifest file, guys. In the PV in the sense storage class only. So this is the name, right? AWS EBS PV is the name of the storage class that I am creating. This name I am mentioning in my PVC definition so that it can understand that 10 GB volume has to be created using this particular storage class name. This storage class will tell the details. This 10 GB volume to be created in AWS of type GP2 in 1 year zone. All that properties, it is inheriting it from the storage class. Then the 10 GB volume will be created for you. Are we good with this? This is the AWS environment, and this is my Kubernetes environment, guys. What is happening here? In the Kubernetes, right? In the Kubernetes, I have the pod. In the Kubernetes, I have the pod. For this pod, I need a volume. The volume to be created it in the AWS side, correct? The volume that is getting created in the AWS, this volume I'm planning to mount on this particular pod, correct? Following me? A question for you at this time. Currently, am I working in the EKS or working in the Kubernetes? I'm working in the Kubernetes, not on EKS. EKS is just a managed service to make your life easier to bring back the Kubernetes up and running, right? Anyway, now when you are running some kubectl commands, let's say I will use this manifest file. Let's say I will use this PVC manifest file. If I deploy this manifest file, right? If I deploy this manifest file saying that, hey, Kubernetes, I need 10 GB volume. How would the Kubernetes will connect it to the AWS and create a 10 GB volume for you? Is that the right question here? Right? When you are asking the Kubernetes to create a 10 GB volume, the Kubernetes somehow has to connect it to the AWS and then create a volume, then use that volume and mount it here, correct? So it won't be by default, guys. At least in the Kubernetes 1.23 version. Till 2.3 version, this operation was handling by the cloud control managers. Remember in the Kubernetes architecture, I was telling about the cloud control managers. right? That take care of these integrations automatically. In the latest version, it will not be happen automatically. You need to install the EBS drivers. If you install the EBS driver software in the Kubernetes, then the Kubernetes will use this driver software to know how it can connect with the AWS and can integrate with the AWS to create a volumes and all. Without these drivers, this will not work. So these drivers, we can even call it as a CSI drivers. So that is the reason I'm explaining these things rather going and deploying the PV and PVC, because without the drivers, it will not work. Without drivers, it will work if you are using the Kubernetes 1.23 version. If you are using anything latest, it will not work. These drivers has to be installed first. Are we good with this? And of course, like when you deploy the Kubernetes cluster using Terraform, you might have been using some IAM roles and all, right? So somehow it will take all of these role permissions and all. It will do the stuff. I don't want to make it more complicated, but yes, to make it simple, you need to deploy the CSI drivers to make these things happen. For today, at least, let me deploy the drivers and prepare the PV and PVC. Right? So this is the article that explains you how to use the EBS CSI driver software, how to install that in the Kubernetes, all these things. So you just need to follow this documentation. So it will give you all the manifest files, all the related stuff and all to deploy this. We just need to go through these steps and get the things guys. Right? We have everything handy ready here. But I collected this whole information and I prepared or I downloaded the required manifest files as per their documentation. So I will just use them for now. It should be somewhere in my, where is that? So I just have downloaded that EBS CSA driver manifest files. Let me get that. Here you go. You see here AWS EBS CSA driver, and it is downloaded as a Helm template or Helm chart. So let me deploy them, guys. Probably I need to clone this. I'm just trying to deploy the EBS CSA drivers. So now let me go to this folder, go to AWS EBS CSI driver. This is a Helm chart, right? Let me deploy it as Helm install, let's say AWS EBS, take the Helm charts from the present working directory. You can download this CSI driver from their documentation only. Just download and install. You don't need to do any more single change. It's done. Okay. So it is currently deployed. right? If you do kubectl get pods on the kube hyphen system namespace, um, there should be somewhere. Is it in default namespace? You see in the default namespace there is something like EBS CSI something something, right? So basically this is the CSI driver related pod that is currently running. This is now taking care of doing this volume creation, all these things. That's how we need to deploy the drivers case. Now let me go back and deploy our manifest files. The first one is I need to deploy the PV. Copy the PV manifest file and pv.yaml. kubectl. So here you can see that I'm using 1A zone. That's okay. kubectl apply -f pv.yaml. Sorry, I'm in the different folder, right? It should be Jenkins hyphen. Let me come back to the folder where I want it to be. Where it is, guys? Jenkins hyphen master, right? Cool. Yeah. Now kubectl apply -f pv.yaml. I'm creating the persistent volume. Done. Then I need to create a persistent volume client. PV is just a storage class. The PVC is actually the EBS volume. pvc.yaml file. I'm telling that I need a 10 GB volume, right? kubectl apply -f pvc.yaml. kubectl get the PVC, right? So currently it is in pending state. Let me wait for some time. Still pending. I'm expecting that it has to create a EBS volume on my AWS cloud. In AWS, it has to create a volume in that zone. That volume I can use it in pod for mounting purpose. I know you are wondering now. We thought of creating the pipeline today, but we ended up with a lot of other things, right? It's not created yet. So it is still in pending state. Let me see what is the reason why it is in pending. Probably rather me using kubectl to troubleshoot. Let me use my Kuberenetes. Right, I'll go to PVC. This is currently pending. I'll go to describe. Right, and you see the error here. The provisioning is failed, okay? And it is complaining that CSI driver failed to provision the volume with a storage class, could not create a volume, in EC2, and it is saying that unauthorized operation. You are not authorized to perform this operation. There is a permission issue. Where the permission issue? EDEK's worker, right? That is the IAM role that is attached to the worker node, okay, or to your Kubernetes nodes. So that role is not authorized to create a EBS volume, and that is where it is getting the problem. Obviously, right? As I said some time back, Kubernetes will use the IAM role backend in order to access the AWS and start creating the IAM, sorry, volumes and all. So it is not having the permission there. So hence it is not able to create it. We'll fix that, not an issue, right? Uh, but once it is created, let's say it is created, right? So this is the name, right? Jenkins-PVC is the name, correct? That is the name that you need to tell in your deployment file how that volume will be get mounted it into the pod level. I'm just showing that syntax now before we get that fix. Let's say if the volume gets created in your Jenkins deployment file, this is the Jenkins deployment file, right? In the Jenkins deployment file, this is the syntax that you need to use. This syntax says that, hey, there is a persistent volume climb with the name called Jenkins-PVC, right? This PVC, take it and that has to be mounted it into this particular folder. That is the syntax meaning here, right? So then when you use this deployment manifest file, right, the Kubernetes will take this persistent volume climb, which is your EBS volume, that will be get mounted it into this particular directory inside your pod. Then any data that is storing in this folder will go to this PVC, which is your external volume. So when the pod gets destroyed, your PVC is safe. And the later when the pod gets created, as per this definition, again this PVC will be get mounted on the same location. That's how it can access the same data. Good with that? Probably we'll see tomorrow because we ran out of the time today. So meanwhile, I'll fix the permission issue. Probably when I'm deploying the EKS cluster using this Terraform code, this is where I create the IAM roles, right? Probably this is the role, right? This is the role. For this role, I need to give the, you see, these are the permissions. Probably, yeah. I need to give the create volume permission as well so that it will gain that permission too to do the volume creation. Then that will fix the problem. But you got me right how I'm going to the troubleshooting process. I just need to add the policy here so that it can get the permission for creating the volumes also. Maybe that's the story for today, guys. Right now, if I come back to my same folder where I was in, I'll fix this IAM policy by tomorrow. If I come back to this folder again, now if I come back to my planning, the README file, you see, I thought of preparing the Jenkins master, and I'm still working on the Jenkins master only to make it as a perfectly persistent storage application. And I'm handling the PVC concepts as of now here. Once the master is fully ready, then we will move ahead with the other steps as well. Any questions, do let me know, or else we're good for today. The reason why I'm covering the PVC and other things today, I can't simply go and talk about PVC, right? We should have the concrete use case why we are doing the PVC or why we are using the external volume. Now it's very easy to understand that there is a data loss, hence we need to have the PVC. And I'm just waiting for this use case to be available for covering the other concepts too, guys. I just don't want to cover simply to complete that particular topic. So I just waited for this And as part of me proceeding with the next steps, there will be a lot of new unknown things will come up, and we'll be talking about those things one by one. Any questions, do let me know, or else we are good for today. Now going back to the questionnaire, right? Kubernetes storage classes. Since I am using AWS as my infrastructure platform to provision the infrastructure, I'm using the EBS volume, but the Kubernetes is supporting the different storage classes as well. Maybe you can see the list here. You can use the, where is that? Where is AWS? That's okay. We can use the AWS EBS volume. We can use the Azure. We can use the Flex volume. We can use the local volumes, NFS, right? There are many. So whichever the volumes type that are comfortable for your specific infrastructure, you can use the same. In our case, AWS is the suitable one. I'm using the AWS volume, but it supports many other volumes types as well. We need to use any of these guys. I think we'll get the complete list as well. Yeah, probably this is the complete list. That's how it works. Any questions, do let me know, or else